At 13:47 hours in occupied Zaporizhia, 12 Ukrainian drones are screaming toward a Russian ammunition train at 97 kilometers per hour. But the operators controlling them don't know that Russian artillery has already found their position. The first 152mm shell lands 800 meters away, close enough to shake dust from the ceiling. The Russians detected them the moment 48 brushless motors powered up simultaneously. That electromagnetic spike lit up every sensor within 10 kilometers like turning on stadium lights. The operators have a choice: abort and survive, or continue while under fire. They have roughly 12 minutes to reach the train. The Russian artillery needs maybe 3 minutes to find them. They decide to continue the mission. A BTR spots the drone swarm and opens fire, tracers arcing through the morning air. The formation splits instantly. 4 high, 4 low, 4 straight through the middle. Machine gun rounds zip through empty space. But here is what the Russians can't see. Each drone trails a fiber optic cable thinner than a fishing line. While Russian jamming floods every frequency with 10 kilowatts of interference, these cables carry data at light speed, completely immune. The $10 million electronic warfare vehicle below them might as well be a very expensive paperweight. While the drones were now on their way, Russian artillery had found the operator's exact location and started pounding the position. But the Ukrainian operators had prepared for this. They'd positioned themselves in 3 separate bunkers spaced 500 meters apart, and here's why that specific distance mattered. A 152mm artillery shell creates a lethal radius out to 300 meters. At 500-meter spacing, even a direct hit on one bunker wouldn't affect the others. The Russians could eliminate one bunker, maybe 2 with incredible luck, but never all 3. 8 drones would always survive to complete the mission. The second round landed 600 meters away, closer but still searching. Through the lead drone's camera, the operator could see the target clearly now. Black diesel smoke rising from the train. It was approaching an area where the track ran straight for 2 kilometers through open terrain, too far from defensive strongpoints, too exposed for close protection to matter. The Ukrainians had studied this route for weeks. The window would last exactly 97 seconds. The third round impacted 450 meters away, and this one changed everything. Shrapnel from the explosion whizzed through the air at 1,500 meters per second, and 3 pieces found their marks: the fiber optic cables of drones 2, 5, and 8. The cables, only 0.8 millimeters thick, severed instantly. These 3 drones immediately switched to backup battery power and radio control. But that meant they were now vulnerable to jamming. The other 9 drones, their fiber optic cables intact, continued transmitting data through pulses of light racing through glass at 200,000 kilometers per second. The operators in Bunker 1 made the call: continue the mission while relocating. As they grabbed their equipment and moved to the backup position, the 4th artillery round slammed into the ground just meters away, but they were already gone, sprinting through the connecting tunnel to Bunker 4, 700 meters to the east. The artillery would have to reacquire, and that would take time they didn't have. Though 3 drones were now vulnerable, the 9 still connected by fiber optic cables were completely immune to the electronic warfare. Radio signals travel through air and can be disrupted by flooding those frequencies with noise. But fiber optic cables transmit data as light bouncing through glass fibers. Jamming radio waves to stop a fiber optic signal is like trying to stop someone's flashlight by shouting at it. The physics simply don't interact. The 3 drones on radio backup, however, were about to face their first real test. The R-330ZH Zytel electronic warfare vehicle positioned at the rail junction detected the drone swarm at 7 kilometers and immediately activated its transmitters. 10 kilowatts of electromagnetic energy flooded every frequency from 100 megahertz to 2 gigahertz, enough power to overwhelm every commercial drone control channel, GPS signal, and radio communication within 30 kilometers. The 3 drones running on radio backup after their cables were severed went dark instantly. Their screens turned to static, but the other 9 kept going on. Inside the Zytel's command cabin, The operator watched his waterfall display change as the system began pumping out even more energy. Every frequency was saturated with its jamming signal. He'd successfully created an electromagnetic bubble 30 kilometers wide. On his scope, 3 drone signals had winked out instantly, but 9 others kept coming, their signals impossibly clean. He checked his equipment, confused. How were they still transmitting through 10 kilowatts of jamming? The operators tried switching frequencies, 2.4 GHz to 5.8 GHz, and every known military band. Soon, the Zytel was broadcasting noise across the entire spectrum. It's like trying to have a conversation in a room where 1,000 speakers are playing different songs at maximum volume. The 3 drones on radio control were now flying blind, continuing on their last heading until their batteries died or they hit something. But here's the beautiful irony of electronic warfare. It's indiscriminate. The Zytel's massive jamming field didn't just affect Ukrainian systems. The BTR-82A crew at Checkpoint 9 could see the drone swarm approaching on thermal imaging and tried to radio a warning to the Pantsir air defense system 3 kilometers away. Nothing but static. Their military radios were just as dead as the Ukrainian frequencies. The Russians had blinded themselves while trying to blind the enemy. The 9 drones with intact fiber optic cables flew on completely unaffected. The Zytel could pump out 100 kilowatts and it wouldn't matter. The $10 million electronic warfare vehicle, designed to knock NATO drones out of the sky at 30 kilometers, was absolutely powerless against drones connected by what was essentially very long fishing line. The train engineer, warned about possible drone activity during his mission briefing, pushed the throttles forward. The convoy accelerated from 42 to 48 kilometers per hour, then 52, finally maxing out at 56, the absolute limit for 4,000 tons of cargo on aging track. But acceleration created a new problem. Every kilometer per hour faster meant the intercept point shifted 17 meters further down the track. The Ukrainian operators had to recalculate continuously, each course correction burning battery power they couldn't afford to spare. The BTR crew at Checkpoint 9 had exactly 8 seconds to engage. That's how long the drone swarm would remain in their engagement envelope as it crossed perpendicular to their position. The gunner traversed his turret, trying to calculate the lead angle for targets moving at 27 meters per second. At that speed and angle, he needed to aim 15 meters ahead of where the drones were. He opened fire with the PKT machine gun, 800 rounds per minute arcing through the afternoon air. By the time he'd calculated the proper lead and walked his fire onto the flight path, the swarm had passed behind a tree line. 8 seconds to acquire, track, lead, and engage 9 targets the size of dinner plates moving faster than highway traffic. The geometry was impossible. Every round missed. The BTR gunner had trained for this scenario countless times in simulators, but reality was different. In training, targets moved predictably. The drones jinked randomly every 2 seconds, up, down, left, right, like drunk hummingbirds. Through his sight picture, he could see the fiber optic cables trailing behind them, glinting in the afternoon sun like spider silk. He tried to lead them properly, but it was like trying to shoot the shadow of a bird. By the time you aimed where it was going, it had already changed direction. The BTR commander pounded his fist on the turret. He couldn't even report the miss because the radios were still jammed. The 9 surviving drones pressed on toward the train, now 4.2 kilometers from intercept. But the Pantsir S-1 air defense system at the rail junction had detected them on thermal imaging. This radar, designed to track cruise missiles, filtered out the tiny drone signatures as ground clutter. The operator switched to electro-optical mode, manually tracking the incoming swarm through what was essentially a very expensive telescope with guns attached. But despite this, the Pantsir would prove that sometimes one lucky shot is all that's needed. The Pantsir's twin 2A38M autocannons opened fire at 3,200 meters, but the gunner wasn't trying to hit individual drones. That would be like trying to shoot mosquitoes with a rifle. Instead, he set his 30mm shells for air burst detonation. Each round was programmed to explode at a preset distance, fragmenting into 400 pieces of steel shrapnel in a 4-meter sphere. At 5,000 rounds per minute, he was creating a wall of metal between the drones and their target. Drone 6 vanished in an orange fireball at 2,900 meters. 3 seconds later, Drone 11 exploded. The 7 surviving drones immediately scattered in 3 dimensions. 3 climbing to 200 meters, 3 diving to grass height, 1 maintaining altitude but jinxing laterally. This forced the Pantsir gunner to make a choice. The Pantsir was designed to stop Tomahawk cruise missiles and F-16s, threats that behave somewhat predictably. But these drones moved like angry wasps, and the gunner faced an impossible choice. His computer recommended engaging the high group. They were easier to track against the sky. But his training said engage the closest threat first. He had 2 seconds to decide. He chose the high group, not knowing he'd just repeated the same mistake that got another train wiped out 3 weeks before. He elevated his barrels toward the climbing group, committing to that target set. Classic mistake in air defense. You always engage the closest threat first because it has the least time to react. While the Pantsir's guns tracked upward, chasing the climbing drones, the low-altitude group accelerated toward the train unbothered. The gunner realized his error, but couldn't traverse fast enough to reacquire. The low drones were already past his optimal engagement angle. But this wasn't the only wall of lead the drones had to fly through. As they closed in on the tracks, a platoon of Russian soldiers at Observation Post 7 added their firepower. 40 AK rifles firing in synchronized bursts. But the shot was near impossible. The drones were crossing perpendicular to their position at 27 meters per second. At 200 meters distance, each drone spent exactly 0.74 seconds in a soldier's sight picture. Human reaction time is 0.25 seconds. Target acquisition and aiming takes another 0.5 seconds. By the time a soldier could squeeze the trigger, the drone was already gone. Meanwhile, 4 special drones that had been flying 500 meters altitude dove toward the railroad tracks 800 meters behind the speeding train. They released their payloads simultaneously, thermite charges that ignited on impact with the rails. Thermite isn't an explosive. It's a mixture of aluminum powder and iron oxide that burns at 2,500 degrees Celsius. Railroad steel burns at 1,370 degrees. The thermite ate through the rails like acid through paper, transforming 4 sections of track into puddles of molten metal within seconds. As the drones continued their approach, the Pantsir's barrels glowed cherry red from sustained fire. Modern autocannons can maintain maximum rate of fire for approximately 45 seconds before heat warps the rifling. After that, rounds tumble instead of spinning, and accuracy becomes worthless. The gunner had no choice but to cease fire for cooling. This created a 12-second window, an eternity in combat, where the sky was clear. 7 drones pushed through the gap. Battery warnings flashed amber on the operator's screens. The fight against headwinds and constant course corrections had drained power faster than calculated. Drone 3 showed 18%, Drone 7, 21%. They needed 30 more seconds to reach the train, but had maybe 20 seconds of powered flight remaining. Smoke from the thermite-ignited grass fires drifted across the battlefield on the afternoon wind. Thermal imaging can see through darkness, rain, and fog, but not through smoke. The carbon particles absorb infrared radiation across all wavelengths. For crucial seconds, every Russian defense position lost visual contact. The drones punched through the smoke at 1,400 meters from target, their cameras showing individual details on the train cars, unit markings, rust patterns, and even the white stenciled warning on Wagon 22. Class 1.1 explosive. The fiber optic cables were approaching maximum extension. At exactly 12,000 meters, they would release automatically to prevent tangling. 10 seconds to release. 5, 3, 2. The first cable released 13 meters short with a simple spring-loaded mechanism originally designed for fishing reels. Drone 1 transitioned to battery power, now 8% remaining, enough for maybe 18 seconds if everything worked perfectly. The other cables released in sequence over 3 seconds. Drones were now flying free, no longer immune to jamming but also too close to stop. 1,053 meters from impact and closing at 27 meters per second. The train engineer saw them through his windscreen, 7 black dots growing rapidly larger against the afternoon sky. He slammed the throttle forward past the mechanical stops, overriding every safety governor. The diesel engines immediately redlined, but pushing harder actually made things worse. The driving wheels lost traction and began spinning on the rails. Steel on steel has a coefficient friction of 0.78 when static, but once the wheels start slipping, it drops to 0.25. The harder he pushed, the more the wheels polished the rails instead of gripping them. The train actually lost 2 kilometers per hour, but he kept going. The Pantsir tried one final engagement, but the drones had entered its minimum range, 500 meters, where the autocannons couldn't depress below -5 degrees. The system was designed to engage cruise missiles and aircraft approaching from above, not ground-skimming drones. $20 million of air defense technology, defeated by basic trigonometry. The gunner could only watch his screen as 7 drones disappeared below his engagement envelope. Russian soldiers at the final checkpoint opened fire with everything they had. Machine guns, AK rifles, even RPG-7s detonated as improvised flak bursts. But the drones were following the exact center line of the railroad tracks, using the 600-meter train as cover from lateral fire. To hit the drones, the soldiers would have to shoot through their own train. The geometry protected the attackers perfectly. Drone 3's battery died completely at 100 meters from target. The motors stopped instantly, props windmilling uselessly, but the drone's momentum carried it forward. At 97 kilometers per hour with minimal air resistance, the dead drone would glide the rest of the way there before the aerodynamic drag could stop it. The operator had calculated this perfectly. The drone would coast the final distance on physics alone. Through the last functioning camera, the operator watched Russian combat engineers attempting to decouple Wagon 22 while the train was moving. The coupling was under 4,000 tons of tension at 56 kilometers per hour. The safety mechanism was specifically designed to never release under load, preventing catastrophic separation during normal operation. The engineers might as well have been trying to untie a knot made of steel while it was being pulled by bulldozers. Drone 9 caught a lucky burst from a PKM, shrapnel clipping its battery pack. It tumbled into the wheat field 400 meters short. 6 drones remaining. The operators had calculated for 60% losses from the start. They only needed 4 hits to achieve mission success. The margin was still positive. At 13:59, the lead drone slammed into the coupling between the locomotive and the first wagon. The RPG-7 warhead detonated on impact. Its shaped charge creating a jet of molten copper moving at 2,800 meters per second, 9 times the speed of sound. The massive steel coupling pin sheared instantly. 4 more impacts followed in precise sequence. Wagon 3's fuel valve assembly ruptured, spraying pressurized diesel. Wagon 7's brake line severed, locking every trailing wagon's wheels. Wagon 18's thin-skinned ammunition car took a direct hit, starting a chain of secondary explosions. Wagon 22's ventilation system was penetrated at 13:51 and 18 seconds. Inside Wagon 22, 12 tons of TOS-1A thermobaric rockets had been slowly heating from vibration-damaged seals. The warhead impact pushed the internal temperature past 447 degrees Celsius, the auto-ignition point. The fuel-air mixture detonated with a pressure wave propagating at 3,000 meters per second. Wagons 20 through 24 simply ceased to exist, vaporized into plasma. The blast wave lifted wagons 25 through 47 completely off the rails, flipping them end over end across the countryside. The mushroom cloud climbed to 1,400 meters. In 4 seconds, $4,800 worth of modified racing drones had erased $127 million in Russian military assets and severed the only rail line feeding 3 mechanized divisions preparing for tomorrow's assault. Bye for now.